Algebra I 10.6a, Solving Rational Equations. A rational equation is an equation that contains one or more rational expressions. So it would be like 1 over a is equal to 1 over 4 minus a. That's a rational equation. Or x plus 6 over x equals negative 5. That's a rational equation. And even x squared over x minus 1 is equal to 1 over x minus 1. That's a rational equation. So just remember, equations have an equal sign and both sides need to balance. Okay? So all of these have an equal sign in between the rational expressions, don't they? To solve a rational equation, we multiply on both sides by the LCM, the least common multiple, of all the denominators. It's also the LCD, or least common denominator. So if we see 1/3 is equal to 1 over 4 minus 1, the least common denominator is 3 times 4 minus 1. See? That's the LCD, or LCM, okay? All we have to do is multiply each side by this 3 times 4 minus 1. And I put it over a 1 as a fraction because these are fractions, so I can just multiply the numerators and then multiply the denominators. You don't have to if you don't want to. So 3 times 4 minus 1 times 1 gives us 3 times 4 minus 1 on both sides, doesn't it? Because it's just multiplied by 1. And then 1 times 3 is 3, and 4 minus 1 times 1 is 4 minus 1. So now this is our new rational equation. And we can cancel these out, can't we? These two 3's. And we can cancel out these two 4 minus 1's, can't we? And what we're left with is 4 minus 1 is equal to 3. See? So we're going to do that with some variables, okay? We're going to do that with x. So here's the exact same problem, except now we've got x. All right? So we've got 1 over x is equal to 1 over 4 minus x. All right? So we know that x times 4 minus x is our least common denominator. It's our least common multiple, okay? So we need to multiply both sides by this, all right? And I'll just put it over a 1 because these are fractions, and I want to just go multiply straight across numerators and straight across denominators, so that makes it easier for my eyes, okay? So x times 4 minus x times 1 gives us the x 4 minus x, doesn't it? And same thing on this side. It gives us that because it's times 1. And 1 times x is x, and 4 minus x times 1 is 4 minus x. Now we can cancel out this x over x, and we can cancel out these two 4 minus x. And what we're left with is 4 minus x equals x. See? Now we can just isolate that x. So what we can do is, because this is 4 minus x, we'll add x to each side. That'll create a 0 pair here, won't it? And eliminate it. And on this side, we have x plus x. That gives us 2x, doesn't it? See? So now we've got 4 equals 2x. Now we can divide to isolate this x. We'll divide both sides by this coefficient 2 to isolate this x to one side. 2 divided by 2 is our buddy, the invisible 1 identity property. So we just have an x. And 4 divided by 2 is 2. So we know 2 equals x. See? That wasn't that bad, was it? All right. Still getting over my cold, so my voice is still a little strange. Sorry about that. So now to check it, we take our 1 over x equals 1 over 4 minus x, our original problem. Okay? And we plug in 2 wherever there's an x. So instead of 1 over x, we have 1 over 2. Instead of 1 over 4 minus x, we have 1 over 4 minus 2. Is 1/2 equal to 1 over 4 minus 2? Yeah, it is. It's 1 over 2, isn't it? So that's true. That's correct. All right? Always remember to check it. All right? Okay, so now let's look at this one. We have x plus 6 over x equals negative 5. So we're going to rewrite x as a fraction over 1 to make it easier for our eyes. Okay, so we're dealing with a couple of fractions. And just remember, if one of the addends is a whole number, just rewrite it as a fraction over 1. Like 5 would be 5 over 1, or even 5x would be 5x over 1. Even if it said 5x plus 15, you could put 5x plus 15 over 1, couldn't you? All right? So now we've rewritten it as a fraction over 1, and this is what we've got. So our least common denominator is x, isn't it? It's just 1x. See? So let's multiply each side by x, and I'll do it over 1 because these are all fractions, okay? So x times x is x squared, and x times 6 over x, here's the x over 1 times 6 over x right here. I just rewrote it, see? I didn't distribute it fully. I distributed this to get here, and now this is the next part. I got x times 1 times 6 over x, see? And when I do this, I can cancel both this x and this x, see? And when I simplify it, I end up with just a 6 over 1, see? See how I did that? And I can rewrite this so it's not a fraction anymore. We can just pull these ones out, can't we? So we've got x squared plus 6 equals negative 5x. Now, this is a second degree equation, so we have to set the equation to equal 0. What's a second degree equation? Little x tells us they contain powers of x that are positive integers, and in a second degree polynomial equation, the greatest power is 2. Okay? So all we have is x to the second power, or just x, don't we? We don't have anything bigger than that. We don't have it to the third power, fourth power. Just 2 is the greatest, okay? And we've only got one variable. We just have x. So because there's no y or z or a or b or c or any other variable, we just have x, we set it to equal 0. There's just one variable, see? So the only way to solve it is to set it to 0. Now, we covered this. It's the principle of zero products. We covered this in 6.8a and b, and I'll have a link to that in this video's description, okay? So you can go back and reflect on it if you need to. Even after I explain this, you still may need to review, okay? So we set this to equal 0, and the way I do it is, since this is a minus 5x, I'm just going to add 5x to each side. And that'll cancel that out and make it a 0, and because we have to do this in order, x squared would be the first one written, 5x would be the middle one, and then the 6 would be the last one, so it ends up getting written like this, because we have to do it in exponential order, don't we? This to the second power, this to the first power, and this doesn't have one at all. So it goes in this order. And we set it to equal that 0. Now we can factor this. And this trinomial factors as x plus 3, x plus times x plus 2. All right? And there's going to be a link to my factoring playlist if you need to review how to factor, okay, if you don't remember, because it was a few chapters ago, so I don't blame anybody if they've forgotten, all right? But you might want to take out 20 minutes to review factoring so that you can move forward without any confusion, okay? So now we've factored it, and it equals 0. So using the principle of zero products, we've got x plus 3 equals 0, or x plus 2 equals 0. We need to isolate this x. So on this one, because it's a plus 3, we do minus 3 on each side of the equal sign, and we get x equals negative 3. And this is a plus 2, so we subtract 2 on each side, and we get x equals negative 2. See? Because these cancel out. All right, so now we've got that x is equal to negative 3 or x is equal to negative 2. Which one is it? It's this one or this one. So we check it. And we plug in negative 3 into our original equation, x plus 6 over x equals negative 5. That was our original equation. So we plug negative 3 in to see if it works. And instead of x, we have negative 3 plus 6 over negative 3. Well, 6 over negative 3 is a negative 2, isn't it? So we have negative 3 plus negative 2. Yeah, that equals negative 5, so that works. Now look at this one. Now let's plug in negative 2 to see if it works in our equation. So we have negative 2 plus 6 over negative 2. Well, 6 over negative 2 is a negative 3, and negative 2 plus negative 3 is negative 5, so that works. So there's two solutions to this, negative 3 and negative 2. See? It's OR. So remember, when you have a second degree equation, it only contains powers of x, all right? So x is the only variable, and it doesn't have to be an x. What if there's just an a here? Well, if a is the only variable, it's still a second degree equation, okay? And if the greatest power is a 2, it's still a second degree equation, all right? That's when there's one variable and the power doesn't go above a 2, all right? And you can set it to 0 to solve it. All right. Our next video is going to be 10.6b, and I'm going to talk about rational equations and extraneous solutions, okay? Extraneous, it's like extra. If you want to go back and watch the videos that we've covered already, any one of these, they'll all be in this description and the factoring one, okay? So you might want to review that principle of zero products, all right? Because I know that was a while ago. Okay, we're going to talk about extraneous solutions in our next video. I hope to see you there, and I hope you're doing all right. Bye.